Because.
All right, I don't want to waste people's time today. We have a good bit to get through. So I made the decision last week to cut quiz 3 and quiz 4 where I needed to, which requires that we get through continuous integration. But it's unfair to you if we have a quiz and I haven't asked if there are questions on the study guide. So I want to first today go through and ask, does anyone have anything that they would like me to go over in the study guide? Then we'll cover continuous integration. And as there's time at the end of that, there might not be time, but if there's time at the end of that, I'll go back to more questions on study guide. So does anyone have anything for me at the moment? Yeah.
Everything?
I would answer that if it were a question.
Yeah, sorry.
Since we went over a lot of design patterns, and one of the questions is like specific on which ones we discussed in class, could you kind of list off
Yeah,
those?
yeah. Everything that we discussed from Refactoring Guru. So I will have an expectation that people have a high level understanding of each of those design patterns, at least enough to be able to determine which one would be the right choice given a problem. I think that's the most likely thing that I will ask people, and I can be very straightforward about that because that really is the level that I care to cover them at. I think it's unfair to people to expect more than that, given that we didn't dive into any more detail. I did though note that I uploaded slides, my own slides from 212, going over some of those patterns. So those are the most used patterns. They will probably be the most targeted patterns among those. So give those a look if you want, if that will help you. Other than that, just knowing the overviews of the Refactoring Guru site should be enough detail as long as you can really iterate those patterns. So I would throw a good chunk of that on your note sheet, especially for those patterns that are somewhat similar. But it's a really good question. The one over here?
My question was note sheet, where are you on the note sheet again? Right?
Yes. Yeah, always. Other questions?
Continuous integration.
Let's continuous integration. We'll certainly get to that. We need to cover it at a. It's not the most involved topic, so I feel okay lecturing about it and then having a quiz on it in a couple of days because it's more of a what is it than there's a ton to it. Anything else while people are looking at the study guide? I guess we can move into continuous integration. Remember that quizzes are not worth a ton grade-wise in the class, mainly because we have this large project, and this large project is almost all of what this class is about. So announcements, I will have a peer review for you as soon as I get back to my office sometime today. They will be due tomorrow. I know we love them. It's repetitive, it's annoying, but again, from what I have seen, for the most part, groups are seeing reasonable contributions across, close to across the board. I guess I should also mention that this week is the withdrawal deadline. I'm trying to make a pass over everything to make sure that I'm reaching out to anyone that I am concerned about in any capacity in any of my classes. I don't really envision that being the case too much in here at the moment, but I will crunch numbers and reach out if I feel like there is something that I am concerned about or that you should consider with regards to that deadline and making an informed decision for yourself. But again, I don't really see that being too much of an issue. See, we have a client meeting on Wednesday with a new client. We have Avinash because Tony can't make it. Other questions about where we are? Quiz on Thursday. All right, into continuous integration we go. Let's do it real quick. All right, talking about CI or continuous integration, there are really 4 components to it with regards to the workflow. And then we just tie this process into GitHub, and that's really it. We've talked a bit about it throughout the quarter, but we want to dive into it in enough detail that we know how to use it in GitHub. So the entire purpose of continuous integration is to make sure that tests are built into the build process and the commit process. So to do so, we are going to talk about the 4 components of CI. The first is to locally test. And to locally test, you're just running your own tests on build. So there's going to be some test harness that you've written for your project. And to locally test, you are running that test harness on your own code, on your own local repository. So build the program and run your tests on your own device. Then committing the code to the central repository and reviewing other developers' pull requests. And as you do this, if you're just locally testing, then you are trusting that the code works for those pull requests. Really, if there's anything past the level that you were able to see from looking at their code, then that's going to be buggy. So that's the local test step, and you should not stop there. Because we want to automate the build process, and we're going to automate the build process so that we know that the code builds at all points in time. There's not some kind of build error or build issue. So we want to build the building process into the committing process so that when someone commits code, the project is built and we know that there are no build errors because of that commit. So it would be great if we could automate that process. So remotely build is saying that as we commit code, we are building the code, the project as part of that. That way we are aware in real time if there is a build error and it's due to the code that was most recently committed. Does that make sense? We're still at the point where we're trusting that code works. We get build errors identified by remotely building, but really, if we remotely test, then we have the ability to ensure that every single commit adheres to the test harness that we've developed so far. This is only as solid as the test harness that we've constructed. But if we have a very solid test harness, then we know that every piece of code that is committed does not break any test in that test harness. So now the process is that we're building and running tests on our own devices, which is great. It's ensuring that as we are writing code, it's adhering to everything to the best of our ability. When we commit, we're building the entire project. And the reason that it's not good enough to just locally test and locally build is that maybe there were some changes that were added into the project between when you checked out the project, worked on it locally, and when you are committing back to the project. Some things that have changed between now and then might have broken something. Or rather, the code that you're working on might break something that was committed between now and then that you wouldn't be able to find in your own local build and test environment. So the fact that it's embedded into the actual process of committing the code makes sure that everything works to the best of everyone's ability as you commit that. So we're automatically building. If errors are reported from the build, then the commit is rejected. That way, whatever is in your develop branch or your dev branch is always working. If anyone puts anything there that breaks the build, that code is not merged. It's a merge fail. Same thing with tests. If no errors are reported from the build, then we run all of the tests. If any test does not pass, the merge fails. If all tests pass, then the code merges. So then we pull in the pull request. By the time you're looking at the code, you know that there are no tests that are failing. And that is a wonderful place to be. You don't have to be looking for basic functionality that you have written tests for. You still should be looking for functionality that is not working. There still very much will be bugs that are just bugs that you have not tested for. But that can also identify holes in your testing harness if you are manually reviewing and something just doesn't look right, or you have a question about something that can lead you to find a hole in your test harness. You then go write that test, see that the code fails that test, then send it back to the developer, fix the code, now it passes that test. And so your code reviews can be useful to add to your existing test harness.
So these remote tests and building are gonna be done on feature branches that we're committing before we do a pull request?
Yeah, so you will have to see it when you commit it, you will see that it goes through this process as you're committing it to your feature branch. And then when you do the pull request, it will still run it on the dev version of that and fail when you try to merge it into dev as well. And all of that will be done automatically. There are tools that you can plug into GitHub that do this entire process for you, with the exception of things like define what the test harness is. You will need to write your test harness, but given that you have that, then the actual process of on commit, on action, this is used via GitHub Actions, which is tying some process into an action on GitHub. So on commit, what happens? On merge, what happens? And you'll have the ability to define exactly what processes happen at what steps via GitHub Actions. And then you can just add in the apps that do this, and you're good to go. So you won't actually have to identify and write any of the code to do this. It's just a matter of plug and play, on commit, do your build, do your test, on merge, do your build, run your test harness. Very easy to use, but very useful. So here's kind of here's a roadmap of exactly what happens. You have your machine, you have a CI server, and then you have your Git repository as the three major machines that are working with this. So when you commit to a feature branch on Git, then it's going to trigger your continuous integration. So it runs the CI server, and now the CI server clones the repository, checks out the associated branch that you're working on, builds the project, checks if there are any errors building the project. If there are any errors building the project, it returns to the server, rejects the commit. If the build succeeds, then it runs all the tests. If a single test fails, it returns to the server, rejects the commit. If all of the tests pass, then we allow the merge. And you're free to now have that on your remote project. So this ensures that your remote project is always at the highest level of quality that you can manually verify at this point, with the quality of the tests that you've written with your build environment. Very little can go wrong. Okay, I'm kidding. A lot can still go wrong, but a lot less can go wrong if you use continuous integration. So this is used all the time in industry. If you're at a job and they do not use CI, run. So how do we actually go do it? We should, of course, have a code repository, a GitHub, a GitLab, a Bitbucket, something that utilizes that. And we know that we commit on feature branches. We review those feature branches and merge them into dev. And every once in a while, we release a new version of the product via main. Great. We're doing this already. Step 2 is to start automating. Rather than having an IDE build for us, we don't want to do this at all. We would want to make sure that we have some kind of build system or framework. We're now doing this with either Maven or Gradle in this class, but in general, using any kind of build system for whatever language you are writing in. Make sure that when we do this, we should have fewer steps in our build where possible. But automating the build is very nice. If you are building inside of your IDE, there's no way to make that a continuous integration because different IDEs will build in different ways. It's better to have a single build framework, Maven or Gradle, something that you can export directly to your version control system. Then we have our test harness. So once you have tests written, use a test framework, run a command to test everything. So again, this can be built into your build manager. So if you are using Maven or Gradle, make sure that you have a single command that runs your entire test harness. Then on GitHub, we want some kind of test environment. This is your CI server. Usually this is done in some kind of container where you have a localized bare bones OS that is solely used to clone your repository, build and run. It has nothing else installed on it, just the dependencies that your project needs to run. So you can have no other issues. And if you run into any other issues when testing in something like a user system, you know that it wasn't due to the build and test. It isn't your code. It's something with the configuration of their machine, a dependency that they have installed, a dependency clash. If you have a CI server that is capable of testing without any other dependencies, then you can separate when something goes wrong between your test environment and the actual runtime environment. And that is also very useful in determining where those bugs are coming from. So make sure that this is done containerized in some kind of container. Does everyone know what a container is or used containers before? Anyone raise your hands if you do not know or have not heard of or used a container?
Use them, but I don't know what they are.
Yeah, so they're just a bare bones operating system environment. So it's kind of like it's a very fresh install of usually some Linux box with next to nothing on it. So that even Linux has a ton of dependencies. So it's completely stripped down to just what it needs to operate at the bare bones. So you can do this from within GitHub as well. It's define a server that is used for containers in a containerized environment. So operating system, software stack can be a virtual machine, which is usually how it's done. Contains just what you need, just your dependencies, and is very easy to reproduce. You can clone a container very easily.
Is that a free feature or a paid feature?
That is a great question. That changes on a yearly basis. That seems to change on a yearly basis. Last I knew of, things were free.
Are we gonna use this in our class?
Yes, you will be utilizing CI and containerized environments. So coming for Sprint 4 is some kind of CI workflow. And I'm not going to say exactly what that CI workflow is, except that it has to be able to do this. It has to be able, you need to be able to remotely build and remotely test your project. So once you have all of this, then your build environment is extremely fast and reliable. So builds are fast. This is great. And once you have this process, then you can trigger them automatically. So you set up the ability for GitHub to do this, and then you trigger them on the commit. So GitHub Actions is what does this, but in general, hooks or actions are what they're called. You'll utilize some kind of CI service like GitHub Actions. And then make sure that your checks pass before allowing for a merge. Both commit and merge should fail if there are issues with the build or the test harness.
So it looks like programmers, you don't use much of their own resources on their computer, everything's remotely.
Yeah. Whenever you're in a group project environment, absolutely. You have your own individual work environment, but the goal is to interface that with your group, and that is done via some kind of version control system like Git. And it's done with as many features as you can put on there, and CI is one of the biggest features that you can have. It is mandatory in any workplace environment that wants to get work done. If you do not have something like CI, then you have to be involved with your coworkers at the level that you're involved with your classmates this quarter. And that's great as you're learning, but once you're in a professional environment, it really should feel like a professional environment. And there's no way to teleport you to that point. So this class's environment has not been a fully professional environment because we've been learning the tools as we go. Once you know the tools, then it should feel much more like a job and much less like you're all babysitting each other.
Could you go over a little bit GitHub specifically? I have no idea what GitHub Actions is.
Yeah, so there's a tab for it on GitHub that just launches. I wish I could actually, I can bring up like the documentation for it. So yeah, CI services. This is a little outdated at this point. I need to find some new images for this, but yeah, why don't I actually do that? So something like this. This is the GitHub documentation page for CI. So this is what I would recommend that people read as you're going through this process. So about it, there are GitHub hosted runners and self-hosted runners. You're just going to use a GitHub hosted runner for the moment. No reason to either write your own or use one that is a company sponsored one. So really just some steps. And it's really straightforward. So continuous integration, continuous deployment. So you're doing both CI and CD. So using workflow templates. So pretty straightforward sequence of steps. Main page, there's a tab for actions. In actions, you'll define a workflow. Within that workflow, you will both have the build and the test as different workflows. But then they both happen on commit and on merge. Anything I can further describe from that? It's pretty much I don't know much more in detail I can go than this because it's the steps are pretty. It's there and it's better to go do than it is for me to describe it, just because when you have your project there actually working with it, I'll be much better able to work with you if something comes up as you're working through this, kind of on a more individual basis.
Yeah, I know I've been on the Actions tab before and it just looked like a marketplace of just things to buy.
Yeah,
And
yeah. So you're gonna look for something CI/CD and implement. And there are ones that are sponsored by GitHub. There are ones that are used more frequently. And I think looking through those options some will become apparent for, it's just the bare bones, which is what you need for this project, as opposed to all the bells and whistles that come with others. Yeah, it's actually quite straightforward to set up. But once you have it, it's huge quality of life. Other questions related to continuous integration? It's among the more straightforward topics in the class. All right, so for sprint 4, you will have some kind of CI/CD workflow. Not required for sprint 3, and there will always be also be a requirement for code coverage reporting. And you will need 100% of your model to have code or to have tests written for it. So sprint 4 requirements, not sprint 3 requirements, but coming up starting next week, very last set of requirements is to fully get the workflow so that if you were to continue working on this project outside of this class, that it would be very easy to interface with and that you have some experience with these tools. Anything else? Any other questions on CI? It's a very straightforward slide deck. So we will grab the next one because I much prefer talking about API design. This is a much more interesting and engaging process. As important as CI and CD are, they're extremely important. They're also super straightforward. API design, on the other hand, much less so. So it's much more interesting to talk about. All right. Who's used an API before? Should be everybody. Who's designed an API before? A couple of people. This is why this is so important, is because going from using an API to designing an API, there are very different considerations between them, because this is something that you can really screw up. And if you screw up your API design after your project is released and you have to fix it after your project is released, there's no coming back. It's the equivalent of a terrible first impression. So API, application programming interface, it is really, if you're making a tool, then it is how people are going to interface with your tool, because you don't want to make your code open source. You want to give someone the ability to utilize a tool that you have used. You do not want to show them the inner working of your genius. That is your trademark. That is something that you will want to use to continue to make money off of your ideas. If you give them your API, especially in the, not just the API, if you give them your source code, in the age of AI, someone can feed your source into AI, and then the companies that own that AI have access to your source code. They are able to modify your source code to be able to do whatever it is that someone else needs. And it just does not take a ton of technical expertise to do this. So it's your protection, as well as it is the usability for your program. So you want a layer of abstraction over your implementation, and you will pass and make public that access while keeping the source code near and dear to yourself, because that is your intellectual property. It should not be publicly accessible. If I asked you to Google around and find the source code for Google Maps, who would be able to do it?
Nobody.
Yeah, it's private, but it is a massive public service. In fact, if you want to embed Google Maps into your own web page and utilize that for your own service, you can do so. And you do so through their API. So making a tool usable has nothing to do with the code itself and everything to do with this layer of abstraction that is surrounding that program, that application. So it's the set of commands, functions, protocols, and objects that allow you to interface with that system without utilizing that system. And it is incredibly important for maintaining intellectual property. From a company view, it's a huge asset. And it's important to get right. Bad design is the reason for really bad long-term problems. Once you design your API, it is very difficult to change. If people are actively using your API, and we'll talk about this, changes to your API will brick other people's code. If you have used Google Maps' API in your website, and you're calling certain functions that are privately on Google's servers in order to interface with this, and they change how that works, such that your call no longer works. What happens to Google Maps on your webpage?
Stops working.
Yeah, it's broken. It stops working. If you made this service for someone else, the coder, made a website for someone else and you sold that to them. And then at some point later, their code stops working, they come to you. And then you have to fix it by going to Google and re-implementing their new API to restore that functionality.
I think Google never does that.
Yeah. So if you're designing your own code, you're taking Google's responsibility or roles to try to prevent. You can have very sellable code if you never modify your API or only modify it in ways that extend functionality rather than modifying functionality.
Well, I was just gonna say, the general idea would be, if you had to modify your API, you just have to like retain backwards compatibility and make enough new interesting features to where you hope people will migrate to that. You just never let the old stuff go. You try to encourage a transition to what's new.
Kind of. The issue with that you'll run into this is if you want the same functionality and then you overload a method and say you can work this way with these features and work this way with these features. If someone doesn't look at your API and accidentally implements it the old way rather than the new way, since you're supporting both, or misunderstands your API and implements it the old way instead of the new way, instead of them getting an error or something that forces them to go back to the API and change it, something will work, but just not the way that they think that it should. So yes, that is still extendability, which is great. And that's how most APIs end up working, is that you do extend for that, but there are costs to that, and they should be considered as part of the design of the API in the first place. That is a really good point. So with a public API, you have one chance to get it right. And there are ways to extend rather than modify, but in general, you really want to get it right the first time. So what does a good API contain? Or what are some features or characteristics of it? It's simple. This makes sense. If an API is overly complicated, then from a programmer's perspective, utilizing your tool is going to be unnecessarily complicated. It's easy to learn, which means that if there's a name for a command that should undo, if it's called undo, great. If it's called something that is not undo, it's not easily discoverable. So a programmer should be able to guess what your API's commands are/do based on the naming convention that you use. It should be hard to misuse your API. It should be consistent and symmetrical, and we'll go into exactly what that means. Really, that's naming conventions. And if you say, if there's some way to do something, then you should use the same terminology to undo that something, or to, if they're related, they should be named similarly. It's well documented so that people can easily identify and find the functionality that they're looking for. It should be powerful enough to satisfy the requirements. So there's the associated functionality of what anyone would want to do with your application. It's easy to extend. If they want to take your base code and write additional functionality to it, then they can utilize your code, write their own code, have their own API over your API, and then publish that, giving you credit and of course paying you for utilizing your code as part of their solution in some capacity. And of course, it should be appropriate to the audience. So how do you do this? I guess at this point I should make sure or continue to think about Do we know what it means when we're designing an API? So you're creating a software solution, which means that you need to think about public interfacing with your solution. What does it look like to interface with your solution? How would this look in a UML editor, as an example? You don't want to pass the client your source code as the project. You want to pass them an API. What if they wanted to embed your UML editor in a web page? That's something that you could create. That is functionality that you could allow for, and just have the code that does that, and then have you pass them a method. Here's what the method takes as input. Here is what you can expect as an output for that. Now, in your own website that you are designing, this is the function that you call in order to do that. Have that functionality. Here's how you interface with that. They don't have access to the code that does it, but they have the ability to use it for their own purposes. What other ways could a user want to interface with a UML editor? Anything else they could want to do with it? It's kind of limited. But you can see how anything that you create from here that is a tool, you would want to think about the end user's perspective. So just like you would gather requirements for the implementation for someone, for a client, you can gather the requirements with regards to designing an API. How would people utilize the solution that you are designing? So don't gather their workflow necessarily, just figure out the associated requirements. What do they want to do with your tool? What is their workflow? What do they need it to be able to do? Then you make a spec document, consult with users, make sure that it makes sense, flesh it out over time, and expect that as you start implementing it, that it's going to get more and more detailed. As you design an API, what do you want to consider? Interface principles, things like what classes, methods, parameters, and names are used. Your API is going to be garbage if your design is garbage. If you discover a new requirement and it forces you to gut your entire system and rework it, the API will change. Or you'll have to write adapters for your API, where when someone uses a legacy API call, it goes through a very long sequence of logic to get to interfacing with your code, which makes it very slow and cumbersome and very unnecessarily over-engineered. So if you utilize good design patterns, just good design in general, as you design this, then as your code becomes extendable, then your API also becomes extendable kind of in a one-to-one fashion. Think about resource management. How are you dealing with the resources that this is using? Error handling, what can go wrong? What is done with that? How is that reported? Otherwise, you're going to have to change your API. If you change your API, then others will have to change how they interface with your code. Also think about how much detail is exposed about how you're doing this. Ideally, that is 0. No end user should have access to any details about how your code does what it does. So we're going to dive in a little bit more detail into each of these 3 categories. Interface principles, this is just where your OO design comes out, assuming that this is OO code. So in your API, users have to be able to understand your API. Maybe I can ask people, what is the most confusing API you've ever used? And why was it confusing? Yeah,
There's this API that we use for hackathon called Juice. C++, API, and, there was like barely documentation on it. It's like you turn these objects and would say what they were supposed to do. There was no information because it was so hidden behind stuff. There was no specification on like what things you could, if you were to make a class that was inherited from that class. How would you, what fields existed in it, and there was terrible documentation, so you just kind of. figure it out.
yeah. Interesting, yeah.
Java FX is pretty bad.
Yeah, so how is it difficult to use? Like, what is it like to interface with the API? What do you wish that it did that it doesn't do?
I feel like my feeling with most APIs is that the documentation is just like so terse. There's no examples. It's like they use like 2 sentences to explain something. Tell
Yeah.
me what the parameters are, but they never define what the parameters actually mean.
Mm-hmm.
So it's like, I don't know, it seems like a lot of people are trying to pump out software and they can't be bothered to explain what it means.
Yeah,
So I'm sure there's a lot of good software out there that just sort of like faded into obscurity because
because it wasn't documented
Nobody ever
well, so
explained
that
it.
it's not usable.
Yeah.
That's a great point. Yeah, so the frustrations that you experience as a user is a teachable moment for yourself about how to design something that does better. That is more usable than that, and that's a great point. Adam makes a great point that good software is only as good as how usable it is. So it could be very good software. It's just if it's not documented well, that it's unusable. And there might be some garbage software out there that is documented so well that it's used even though it's garbage because it's just easy to plug and play. The idea, the ideal, I suppose, would be to design really good software that has really good documentation. And then you have the gold standard until there is some kind of technological advancement that might make your code obsolete. So your API should be as small as possible, but not smaller than as small as possible. As soon as you're lacking API functionality, that is extremely bad. But you don't want to have 5 ways to do the same thing, and you don't want there to be unnecessary fluff to it.
I was talking about the Juice API.
Yeah.
I think the only way, because they're like widely used. I think the only reason they get past that, because it's the only API that does that specific thing. It's the only one.
Mm-hmm.
Like even though it sucks, it's the only one.
Yeah, they have a monopoly over it. If you're gonna do it, it has to be through that, or you have to implement it yourself. And you see that there are a lot of people out there who don't want to implement something yourself, especially in something like a hackathon environment where you have to plug and play where you can. It's just that if tool doesn't exist or it isn't well documented, it's very frustrating to use.
Just to piggyback off of the issue of Java FX is core error codes, like unhelpful error codes are annoying.
Mhm.
That
Yeah.
tell you like what you did wrong.
Yeah, if it breaks, then there should be something intelligent that is returned to you so that you know how to move forward. Yeah. Anything else?
it is interesting that like a lot of APIs, there can be like really well-written textbooks on them. So clearly somebody's able to understand it in a really detailed way. But there's part of me that always wonders if maybe if those people helped make it, and maybe even, I also feel like that, like a textbook, like a really integrated textbook is almost like the right way to understand documentation. So it might even make sense for companies just to always publish a textbook with your API and make it like a PDF that's available.
Yeah,
You know what I'm saying? Like,
Yeah.
I don't know.
that seems weird to me to couple that, like you need to purchase the API and like just hide the API behind paywall. Just don't make me buy a book on how to use it. The API should be paywalled or not, depending on use. So that is another option that I probably should specify is that if you design software that is incredibly useful and you don't want it to be widely used or they need to license it in order to be able to use it, you can license your API. So simple, general, implementation can change, but the API can't. So think of this as if you write a program and you have a particular method name for some particular aspect, like let's say you're writing a linked list and you want to add the add at the end functionality to your linked list. You can go completely gut that add at the end code and replace it with something else, as long as you don't change the method name. None of the code that's using that linked list will break. But as soon as you change that method name, now everyone's code, even if the implementation is exactly the same, the fact that you change the method name, everywhere that calls that method now also needs to be changed. Include in your code, in anyone else's code who is using an API key to access that method. So there's a difference between the naming and the functionality. So the implementation can always change any inner guts of your code, but the API, how people are using your code, is unable to change without breaking. Then we mentioned hide information, minimize accessibility, everything should be private. As well as you never know how technical the people who are using your code is, so abstract that to the best of your ability. Again, I like to think of this as the driving a car versus understanding how a car works example. So go back to that to think of, make it as simple as possible to interface with, and don't use implementation details in your API, even if it's how you understand how your code works. Think about it from the end user's perspective. How technologically incompetent can someone be and still use your code? Write your API from that perspective. Maybe some links to some advanced usage if you want to throw a bunch of implementation detail or accessibility, making it more technical. But yeah, be aware of what is in the implementation, but don't specify as much of it as you can get away with. Regular means that across your API, you're handling things in a similar way. Don't change up how you handle something underneath the hood or within your API across the different parts of your source, because someone who is utilizing that will expect that if it's done one way here, it's done the same way over here. If that's not the case, then that is very confusing. If people have dealt with that in existing APIs, it still happens and it's really frustrating when it does. So parameter ordering, if you do something like name followed by GPA, then don't in another table have GPA followed by name. Consistent parameter ordering. The associated inputs, if a person consists of these parameters here, a person should consist of these parameters over here. Don't change up the parameters, the required inputs to things when they should be mapped together. Even if your code doesn't utilize that information, it may actually be useful for consistency across your API. It is a design decision that you can make to make things consistent. In general functionality, names matter a lot. Same thing with naming variables in your program. Very much aids the readability of your API. Use the same naming style. Don't use camel case for some things, underscores for some things. And then try to keep it consistent with other interfaces outside of your API. So if your API is based on another API that you're trying to improve, utilize that same naming style so that people coming from that same product don't have to learn something new. They can use their old information that they have from their old tool, and with minimal learning, use your new tool. You'll get more users that way. It should be predictable. The principle of least astonishment is something that can be used when designing this. So you don't want your user to be curious or astonished when they shouldn't be surprised by the behavior of what they do. If I say add at the end of a linked list and it adds in the middle instead, they're going to be very astonished when they print out that linked list and it doesn't do what they think it does. Even if it costs performance, confusing your end user is way worse than having performance issues. Don't reach behind the user's back. Don't change anything that they're doing. Modifying global and static variables. If they didn't specify that something that they are using is changing, it is going to be very shocking to them when it does change. If there are secret files or anything that's written or information stored about their use without their knowledge. Minimize the use of other interfaces and make sure that you document everything so that the user knows exactly what is happening when they use your API. And I guess we'll do the rest of this next time. Since we are out of time, but API design is hard. There's a lot to consider with it, but it's really important and not talked about enough. We'll talk about it more in a week. There's no class tomorrow.
Are we gonna be implementing an API?
You will not be, because we don't have time. I really wish we could. No.